that the code is all available on GitHub. The link is in the description. The 3D models are on printables, and that link's there as well. I just wanted to show very briefly how this is constructed, just because picture's worth 1,000 words or whatever. So this is the new version of the model. It's available on printables. It's all ready to download. I've printed this in PLA. So far I haven't had a problem with that. Given the way that it's attached, it'd probably be better to be printed in PETG or something more flexible than PLA. Probably ABS is also good. There's a couple of modifications made to it just to extend the roof of the microcontroller housing, and now the branding's on there. The Haltech Wireless Stick V3 just needs a servo attaching on the ground and 3.3 volt line, and the 18 pin or 18 GPIO is for the signal wire. This is just a standard 9-gram hobby servo, and so far I haven't had any problems running it off the 3.3 volt line. It's not the best for it, at least not the best for the microcontroller, but so far no problems. It works absolutely fine. So once the part is printed, the microcontroller, with header or without, depending on how you want to use it, just slides in there. And then we attach the antenna to the hole for it, just there. And then the servo goes with the horn towards the towards the what would be the top. We just use the screws that should come with it. Just to mount the servo. There we have it. What I've used for the pin is just an Allen key. I think it's a 1.5mm Allen key. It's strong and rigid enough that it's not going to bend, and it fits perfectly in the 2mm holes that have been put into the design. You can use a piece of wire if you can get one that's stiff enough and make it into that shape, and you'll have to experiment with the length of it. But this has been designed for exactly this piece. Now what I do to make sure that this is all aligned properly, get the servo ready and the screw. We power this up with the antenna connected. It should automatically zero the servo. Move the pin to the location it needs to be fully open, which is there. Then we can attach the horn. It's fully open and it's not inside the gate. And then we just tighten up and that's it, fully completed. So now there's a little bit of a change with the pairing process. So you'll see now when this is powered on and it pairs with the device, it fully locks and then retracts the pin just to show that it has paired. Turn them on in any order and basically the pairing animation will play until the device is reset and then it'll pair. Same as before, we just press and hold one and it will blink a couple of times. Fully unlock it if it's not already unlocked. and then we press the buttons in sequence to lock them in the different positions, and then again to unlock them. And that's it. The encryption that's on there now, when it pairs, it shares a key which is randomly generated, and then that's shared in plain text to the remote unit. That's obviously not the most secure way of doing it, but for the very short amount of time that these are going to be used, that's absolutely fine. And at least it makes these two things unique in the same frequency that other LoRa devices could be using. To fit this to the battery, and this is where PETG is probably a little bit better than this, you get the battery the right way around, and you can start by pushing in the locking tabs a little bit to get underneath the device. Push it in place, and then it will lock on both sides. And then that's locked very tightly to the battery, which we can then refit to the drone. And there we have it. Yeah, code is in the description. The links to the models are in the description. Don't do anything illegal with it.